All right, welcome back for part 3 of the excuse me, 4.5 activity, 4.5 cam dimension drawings. So far we have gotten to the point we've downloaded all of our items from our Canvas account, and let me pull that up again. And make sure you're logged into your MyPLCW as well if you have not yet. So I'm going to log in right now. Alright, so under 4.5, under your resource tabs, in the first video we went over how to download these files for the new Inventor, so do not do the old. In our second video, okay, let's pull this up here. In our second video, after watching this, everyone was assigned a 1.5 inch cam, and everyone will do a where's it at? Regular hexagonal cam using the cam dimension drawing. So that was in our second video, and this is the third video. So at the end of the second video, I asked you to watch this video here on placing work features in your Cam 3D model. So we're going to go over that now. And then start placing our constraints. So I'm going to open up Automata Simulation. Okay. And then once that opens, it's probably going to say like, hey, where are these files? If not, then it knows exactly where the files are. So changes have been made since that. Okay. Let's see here. All right. So here is our Automata simulation, and once you have that in there, some of these things are going to be locked in, like the follower here or the guide. This is locked in to only rotate this direction. We're going to go ahead and place our hexagonal cam. So I had named mine HexCam Richmond. Yours would be HexCam, whatever your last name was. From the second video. So you should have made a hexagonal cam. We're going to open that up and we're going to bring it into this assembly file. Excuse me. And then how to make these planes come up. We're going to go over that. So I'm going to start first. I'm going to delete my planes and then I'll show you how we got those. Delete. Is there not a delete? I guess there's not a delete. So let's show you how I got to adding those planes. So to do that, we're going to double click on our cam, and now I can probably delete them. I can. All right. Yes. All right. So I double clicked on my cam, and what that does is it ghosts out the rest of the project, and we essentially made a part file within our assembly file. And anything we do is going to edit this, and then when we click return, it'll update the assembly file with the new part file, any changes we made. So let's go ahead and add those planes. Just like the video said, we're going to click here on plane in the drop down, and we're going to do a mid plane between two planes. So that would be in between the front and the back surface of our cam. Excuse me. So if you look at it from the right view here, that yellow line represents that plane, and it divided our cam in half. So next we're going to add a axis that goes through our object here. So I'm going to do a drop down, and through center of circular or elliptical edge, click on that, and then you could click on the back edge or this edge, but it's going to create that. And then if I click on this little dot here and click and drag, okay, I can add a little more axis just to make it a little more visible. And next we're going to add a point. And that point is going to intersect with this axis at the surface. So I'm going to do a point and intersection of plane, surface, and line. So this is the surface I want the point to intersect with, and that line. So now this little crosshair there, that dot right there. That is the point. And it will line up exactly with the face of this surface. And now we're going to create a new plane, and this plane is going to be, where's it at? Parallel to plane through point. So parallel to plane through point, if we open up underneath our part, the extrusion, okay, not the extrusion, origins, my bad. You're going to see a YZ plane, an XZ plane, and an XY plane. We're going to do the YZ plane for this. It's going to split our cam in half this direction. So I'm going to click on that. I'm going to select the point I want it to run through. And now I have my plane there. So that is connected to the axis. So it's split in half. So if I go up here and click return, now my cam will have the two work planes that we are requiring. So let's get into constraining, and we're going to get there. So the first thing you need to do is we're going to constrain it, and we're going to constrain using a mate constraint. And you have two different types of mates. You have a mate where it's going to put two surfaces together, or if you look at the picture, it's going to make two surfaces flush together. So we're going to do a normal mate constraint, and I want to mate the center line of this. So when you highlight it, you'll see the two circles and the center line. I want to select the axis of the hexagon, and I want it to be constrained to the center line of this. So we're going to click on there and apply that. So now, excuse me, now that's going to be constrained to the axis. Now if you notice, you can move it along the axis, but you can't move it to the left or the right or up or down. So it's constrained to the axis, and it can keep on going, but it's going to be constrained to the axis. Next, we want to constrain this plane, all right, that splits our cam in half. That plane that I'm highlighting, I want to constrain that to be flush with the plane of the follower, because we want the follower to ride along the hexagon. So let's go ahead and do that. We're going to do another constraint, and it could be a mate or a flush. Either one's going to work. So we're going to constrain work plane 3 to the work plane of the follower. So apply, and then I'll log out of that. And now if I try and drag and move this, the only thing now it can do is rotate, because it's constrained to the same plane as the follower. Okay? So if we look at it from this, now it's lined up. Those are constrained together. And there's our hexagon. It's constrained, but there are some other things we need to do. For example, when I rotate this, we would want the hexagon to turn, right? So we're going to constrain this blue plane to the XY plane, or the YZ plane of our cam. So let's go and do that. I'm going to do another mate constraint. We're going to constrain work plane 1 to the work plane of the cam. Apply. So now what's going to happen is when I grab the axle handle, okay, and I go to rotate it, the cam will actually rotate with it because they are constrained together. So it's important that you're doing these constraints the right way, and we'll make sure that they follow along. The next constraint is going to be our more difficult constraint, okay, and that is going to create a surface constraint between the bottom of the follower and the hexagon itself, because we're going to want this to bounce up and down as the cam turns. So let's take a look at our MyPLCW, excuse me, to go over that. So we need to mate the plane of symmetry of our cam to the work plane through the center axis of the axle. Okay, so we're trying to do this. To test the constraint, we're not too worried about having this in the test, but let's go ahead and do this. So, excuse me. So we're going to insert an angle constraint to help us measure the angle of rotation. So we want to rotate it, our cam, and orient so the follower is in its lowest position. We're not there yet. Okay, let's go back here. Test the assembly by rotating the handle, attach the axle. The cam should rotate with the axle. Okay, now we're going to do a transitional constraint between the outside edge surface of the cam and the curved surface of the bottom of the follower. So theoretically, when we rotate it, should work. Alright, so let's get into here and see if we can make this happen. Let's go up to Constraints, and you're going to look for Transitional. That's right here. Click Transitional, and we're going to end up selecting two different surfaces. So basically, a transitional constraint is there's movement to this, right? So we want these surfaces to touch, but the surfaces themselves are moving. So we just want to make it so that as this edge passes along, it follows along the edge. So make sure we're highlighting the correct thing. If you do a transitional to surface, that won't work. And if you do just one line, that won't work. What we want to do is make sure the entire edge is a transitional surface, okay? Because we want it to be constrained to that. So let's go ahead and do that. I'm going to select this. Let's try it. We'll see how it goes. To that. Apply. Alright, so that didn't work. Let's try this again. Transitional surface. There to there. Okay. So that might have worked. And I'll do that again. So constrain, transitional surface. Make sure that I have that edge and then that edge, and that worked. So now we should rotate this and the follower should follow along. See how that works? So as each point comes up, the follower goes up, and vice versa. So you might have to mess around with that to get that to work, see what happens. And that constrains that there. So let's continue on with our instructions. Okay. The next part is to test our assembly by rotating the handle, attach the axle. The cam should rotate good. We've done this. So now we're going to test the assembly by rotating the handle, attach the axle. We can turn the visibility of the box off. So let's go ahead and do that right now. To turn the visibility off of a box or any other item for that matter, find it over here in your browser window. So this is the box. I'm going to right click on that, and if I go down to visibility, there's a check mark, meaning we can see it. If I unclick that, now the box is gone. And it's not gone, it's just invisible. So when you're ready to bring it back, go over here, right click on box, and go down to visibility. Alright, but for right now it's just easier to see with the box not being in the way. Okay. Back to our MyPLTW. To test the constraint, try to rotate the axle. The axle should not move. So what that means is we're going to add a rotational constraint. And once we do that, we shouldn't be able to just grab the axle and move it. It should require us to put it in a number. So rotate the cam and orient it so that the follower is in its lowest position. So we're going to go ahead and do that. We're going to rotate this down like that. It's pretty close. And we want the follower down in the lowest position. Next, turn on the visibility of the angle rotation work plane associated with the follower part. So note, to toggle visibility of a feature on and off, right click the feature in the browser and select visibility. So we want to see the angle of rotation work plane. We cannot see it right now. So what we're going to do is we're going to turn that visibility on for that. And that would be within the follower part. So back to our browser menu, look for follower, okay, and angle of rotation follower. There's a work plane already there. We're going to right click on that and we're going to turn on the visibility. So now we can see it. I'm going to turn this one off just to make it a little more outstanding. I'm going to turn this work plane off as well so that we're only left with the angle of rotation follower. And then let's continue on. So turn off the visibility of mate with midplane, and turn off the visibility midplane work plane of your cam. So midplane work plane of your cam. So let's go down to my hex cam, or open that up, and midplane work plane right there. So we're going to turn the visibility off. So the only thing we can see is that in the cam and that for the follower. So let's constrain those now. We want to place an angle constraint with a value of 0. So we're going to do that here, constrain, and then make sure we choose angle. And we are going to select this work plane to be constrained to that work plane with an angle of 0. Make sure we have the right thing selected. So that would be here, directed angle. And we're going to apply that. Don't have explicit reference vector. We're going to do directed angle. So that's there. So theoretically, we should be able to grab this and not do a thing. Okay? It's not letting me rotate. So I can actually change the degrees though in different increments. So let's do like 45. Boom. Accept the relationship. Okay, that didn't work. Control Z. Okay, make sure you're selecting the right angle. We're gonna find that. So angle 1, 45. Nope. Okay, let's try angle 2, 45. Alright, so you'll have to change the angle at angle 2, not angle 1. 90. Let's try 90. Double click on it. 90. Okay. 180. Okay. And back to 0. So, oops. And we're going to accept that. And now it's not working. We're just going to go back. Control Z. For some reason, I don't know. But if you can at least get it to move like that, then we're good. So let's go back to our MyPLTW. At the angle constraints, set the angle to 45 degrees. The axle should rotate 45 degrees, but once the constraint is applied, the axle and cam should remain in the same position. Okay. So this video is going to show that exact thing that we just did. Okay, let me see what's in this video here. Yep, so those are the angles. And next we're going to bring in a ruler. Okay, and this video brings in that ruler, but I'm going to show you how to do it now. Excuse me. So we need to bring in our ruler now. I don't see it in here, so we're going to go up to place, and we're going to find the ruler. Ruler. Open. And we're going to bring that in. Okay. And we want that ruler to line up where it needs to be. And that would be where the bottom lines up with the axis. Okay, that's not wondering. There we go. We want the bottom of the ruler to line up with the same axis as the follower and the cam itself. And then we'll be able to do a measurement of displacement. So let's do that. And then we'll create a motion graph based off the information that we have from our cam and follower. So collect and record data, we're not there yet. So let's go over how to put in this ruler. And we're going to do some constraints here. You just need to make sure that we do the right constraints. So I'm going to do a constraint, and I'm going to do a make constraint. I want the bottom corner, bottom edge, if we rotate like that, I want this line here to be constrained to the axis of that. Okay. And when I do that, that's going to help there. And then I want the surface of this to be constrained to the work plane of our follower. So apply. And then just to make sure that this ruler can't move, because right now it's constrained this way, but I want to make sure that it's not going to move out of the way. I'm going to constrain the face of our hexagon to the side of our ruler like that. Okay. So now if I put in that and I look at it from this direction, you cannot move the ruler. Okay, so we can now do a good measurement of how much the cam moves. Okay, so let's go over that back to here. Once we have that done, you're going to edit the angle constraints, and if you need to suppress it, you can. So you would delete and bring it back instead of right-clicking. So how do I explain this? You can suppress the angle constraint or any assembly constraint at any time by right-clicking on the constraint itself in the browser and selecting suppress. So, for example, without deleting it, but just kind of temporarily removing, let's find the constraint. I'm going to right-click and I can click suppress. And now I can move my items. Okay. I'm going to come back here and I can unsuppress, and it's going to lock back to where it is. Okay, so let's go over the next part. And actually, before I get in there, I'm just going to stop here and I'll do a fourth video. Fourth video. Okay, just making sure. And we'll go over the next part in the fourth video, and I'll just give you some time to catch up. All right, and with that, if you have any questions, talk to your other classmates in the sub. Watch the video again if we need to. With that, have a good day.